Okay, so good day everyone. We are Group 3 and today we will be discussing the topic image formation by a plane mirror. So this lesson is part of geometric optics, which deals with how light behaves when it hits different surfaces. By the end of this presentation, you will understand how mirrors create images, why they appear the way they do, and the scientific principles behind them. So now let's begin. So before we talk about mirrors, we first need to understand how light behaves. So light travels in straight lines, and when it reaches a surface, it can either be reflected or refracted. So reflection happens when light bounces off a surface. Like when we look into a mirror, the angle at which light hits the surface is equal sa angle at which it bounces back. Refraction, on the other hand, is when light bends as it passes from one material to another. For example, objects underwater appear closer or bent because ang light slows down and change iyahang directions. So these two behaviors, which is ang reflection and refractions, are important because they explain why mirrors, lenses, and even things we see every day appear the way they do. Now let's talk about how light rays help form images. So every object around us reflects or gives off light in all directions. When kaning a light abot sa atong mata, we see the object. We can think of objects in two types. First is point object, which is a very small part of an object, and the second one is extended object, which is an object with size like a pencil or a person. In mirrors, the light rays coming from every point of the object bounce off the mirror and travel to our eyes. Ang atuwa dayong brain matrace niya ning rays backward and forms kanang ginatawag na tuog image. This is why when we stand in front sa mirror, we see ourselves. So the mirror sends the reflected light back sa atua. So that is for the introduction. Now let's proceed to the next slide. Thank you.
Good day everyone. Let's start with reflection from a plane mirror. According to the law of reflection, the angle of incidence is equal to the angle of reflection. So this means that the light ray hitting the mirror and the ray bouncing off the mirror make the same angle with the normal line. This line is the perpendicular to the surface of the mirror. So in the diagram, as we can see how light rays from the object point labeled P reflect on the mirror and reach the observer's eyes. So the reflected rays seem to come from behind the mirror. So it creates what we call a virtual image. So this image is upright, meaning it isn't flipped upside down and it appears behind the mirror. However, it's not a real image because the light rays don't actually come from that point behind the mirror. It's just how our brain perceives it. Now let's move on to diffuse versus specular reflection. So when light hits a surface, the way it reflects depends on how smooth or rough that surface is. So on the left, we have a specular reflection. So this happens on a smooth surface like a mirror or still water. So the reflected rays stay organized, which gives us a clear image. That's why we can see ourselves in a mirror. So on the right side, you can see that it is a diffuse reflection. So this occurs on a rough surface like a wall or paper. Here, the light rays scatter in many directions, which means that we don't see a clear image. So even though both types of surfaces reflect light, only smooth ones give us a sharp, mirror-like reflection, while rough ones scatter light, making the reflection blurry or invisible. Finally, let's talk about refraction at a plane surface. So refraction is the bending of light as it passes from one medium to another. For example, from air into water or from water into air. So this bending happens because light travels at different speeds in different materials. So in the diagram we can see that light rays from an object point P bend when they move across the boundary between two media. So the observer sees the rays as if they're coming from the point P, which is closer to the surface. So this bending effect causes apparent depth. That's why when you look at something underwater, like a coin in a glass of water, it appears closer to the surface than it actually is. So refraction not only changes the direction of light, but also affects how we perceive the position of objects in water or glass. And that will be all. Thank you.
So now let's talk about image formation by a plane
by a plane mirror. When light rays reflect off a plane mirror, they follow the law of reflection, meaning the angle of incidence is equal to the angle of reflection, as shown in the diagram. As the reflection rays appear to come from a point behind the mirror, even though they don't actually pass through that point. Because of this, the image form is virtual. It cannot be projected into a screen since the light rays don't really converge there. In a plane mirror, the image distance is equal to the object distance, which means the image appears just as far behind the mirror as the object is in front of it. Mathematically, this relationship is written as S equals to negative S, where S is the object distance and the other S is the image distance. This is why when you stand in front of a mirror, your reflection seems to be the same distance behind the mirror as you are in front of it. So, next, there are sign rules. So now let's move on to the sign rules used in mirror equations. So these rules help us determine whether distances and values are positive or negative, depending on the direction of the incoming and outgoing light. For plane mirrors, the object distance is positive because the object is located on the same side as the incoming light rays. However, the image distance is negative because the image appears on the opposite side of the mirror, that is, it's virtual and not real. So, to summarize, for plane mirrors, the formula we use is S equals to negative S, meaning the magnitude of the image distance equals the object distance, but with the opposite sign. These sign conventions help us analyze and solve mirror problems correctly in optics.
Now, let's move on to the expanded objects. When we say expanded objects, we mean objects that are not just one point, like arrow, your face, or your whole body. Each point of the object gives off light rays that hit the plane mirror that reflect back following the law of reflection, which says that angle of incidence is equal to the angle of reflection. In the diagram, you can see the object on the left and the image on the right. The triangles in the picture are congruent, which means they are exactly the same size and shape. That's why the object and image are equal in size. Just flip left to right, that is called lateral inversion. Also, the image distance between the mirror is equal to the object distance in front of it, which means S is equal to the S prime. To sum it up all, a plane mirror creates an image that is virtual, upright, and the same size as the object. The distance of the image behind the mirror is equal to the distance of the object in front of it. We also learned that reflection follows simple laws that make mirrors work the way they do. Diffuse reflection happens on rough surfaces, while specular reflection happens on smooth ones like mirrors. Refraction or bending of light explains why objects underwater look closer than they really are. These principles are not just science concepts, they are seen in everyday life and technology, like in cameras, eyeglasses, or even phone screens. And that's the end of our report. Thank you everyone for listening.